Thank you for downloading this webinar. Hopefully after this video you'll have a better grasp of why synchronous technology is a game changer in today's industry. So, quick introduction. I'm Chris Morgan. I did my degree at Birmingham City University. I've been using Solid Edge since 2008 and been using Synchronous since the off. I've done quite a few jobs all using Solid Edge during the last 12 years. We can see that I have used another not quite so good CAD system in the past as well. And here's a few little pictures of some of the projects I've done. Okay, so what we're looking to get out of this video, we're going to be looking at a synchronous modeling overview. We'll look at base feature creation, using regions to add and cut. We can look at editing synchronous models, both Solid Edge ones and ones that have come from other CAD systems. We're going to look at reusing features. We're going to look at design intent in synchronous modeling. And we're also going to look at additional features of synchronous technology. If you want to skip to any of those features, you can go to the time point after each one if you just want to look at that set section. So, what is synchronous technology? So it's a patented 3D CAD technology from Siemens that works alongside the history tree. We can make edits to the 3D CAD designs graphically and interactively by controlling dimensions. So from this we can see huge increases in engineer productivity. So we can turn 60-minute tasks into a 5-minute task and 10-minute tasks into 10 seconds tasks, depending on what these tasks are. So let's have a look at a little bit of modelling benchmarking. So on the left you see we've got ordered. This is common to many CAD applications. So the big thing about ordered is there's a lot of work in the sketch environment on there. So you can see there's a lot of time being spent getting the sketch right. Where on the synchronous on the right, you can see we've already got a solid with a couple of different features on there that has been created quickly on the fly. These are both done at exactly the same speed. And we can see that the one on the right is 2 times faster. We'll get through that option 2 times faster than the one on the other side. So if we look at the one on the left, we can see that working on the sketch, trying to make this into a single chain of elements. So we've had to trim this down, extend it, move it, change the size we want. We can do quick trims. There are some really good options in there, but now we need to fully define this. So we need to make sure we're using the appropriate relationships, add in the appropriate dimensions. This is fully defined. The one on the right, we now running through this a second time, so we can see how far ahead we are on the one on the right. So we're going to leave this for the one on the left to get through to the end. So we can see we're checking the sketch, finding the additional relationships that we need. So we just need one more equal relationship. We can then come out of there and extrude that in the distance that we want. So we can see on there we have to go up to the command bar, where in synchronous we can use a quick keyboard shortcut. So we're now having to produce another sketch. So here we're going to use a rectangle by 2 points, quick dimension. So it's very, very quick, this option, but we're still ahead on the second time over on the option on the right. So last one on the left to do is just to put the hole cut out through. But it's all this time spent going in and out of the sketch, which is the same for all mainstream CAD systems that use history. We always have to rely on those sketches. So we are at last done on that one on the left. So let's have a look what synchronous does. As a user creates or modifies a model, it is updated in real time all the time. So we can see, we call this the synchronous solve. So in fact, that's where the name came from. A unique ability to synchronize a solve between rules, features and geometry is what allows such superior capability in model editing. As a user makes a change, either by dragging a face or editing a dimension, only the affected geometry is updated. This synchronous solve manages modifications and updates only the minimum amount of geometry found by key components such as 3D lock dimensions, live rules, and procedural features. Because of the localized solve that occurs, system performance during edits are very impressive. Only a system so complete has the right to be called synchronous technology. So now, rather than dismissing this as just some sort of buzzword, let me introduce to why Siemens created it. So the most common type of CAD system available in the market is called history-based modeling, because it has great benefits, such as being dimension-driven. It's so good, in fact, that Solid Edge has been a history-based modeler for around 20 years now and continues to provide this method. However, we've worked this way for so long that we've learned to ignore the not so good things about it, such as having to pre-plan the model. Looking for a better way to work, we can turn to direct modeling, because this has some great benefits, such as direct interaction with the model, but there are some downsides to this too, such as being featureless, not being very organized. So how about taking the best of both of these and leaving out the downsides? This is why Siemens created Synchronous Technology, with unique items such as 3D driving dimensions and face relationships to really synchronize these worlds. In fact, the technology is so unique to Siemens that the last time I checked there were 8 patents granted with a further 23 pending. So let's have a look at a base feature type. So the first one we'll have a look at is extrude. So this extrudes a shape along a linear path. So here you can see from the image that we select the region that we're going to work with. We select the arrow and we can just extrude that. We can extrude that one way, the other way, or we can use symmetric, just from a quick keyboard shortcut on there. The other type of base features are revolve. So we revolve a 2D shape around an axis. We can do this 360 degrees. We can do it partial. We can also do it symmetrical partial from the initial sketch that was created on that part. So the next one we're going to have a look at is a sweep. This extrudes a cross section along a path. So you can see on the image we select the path, select the cross section, and that has then created our sweep. We've got advanced options are available in the menu if needed, which is on the floating command bar that we've got on there. So it allows us to scale, have multiple paths, multiple cross sections, and also add twist to this if we want to. So here we've got a add and cut example. So when we do any of these options that we've just looked at, we can add or remove material. So both the extrude, the revolve, and the sweep, we can add or remove material very easily using the synchronous tools. So this one, we've used a section to create a solid. We've created a thin wall. In other systems, this may be called a shell. And then what we're going to do, we're going to select multiple other sketches to be used. Notice I'm using the radial menu on there. This means I don't have to go up to my ribbon menu at the top to do the options that I want, and I can choose add or cut. So we can just choose that directly from the menu on there. So next we can select the next region that we want. This has got 4 lines, so what we can actually do is do a fence select over this. So press and hold with the left mouse button. This will then select all those elements at the same time. So here we can do the same thing, or I can actually press the space bar to remove this. So that changes it from add to minus. So this one, we're going to select this one. We're going to do that as an extrude. We're going to go down. We're going to press space bar again. I'm just going to drag that all the way down. So when we spin round and have a look on the underside, we can see that we've now got that cut on there. So we've mentioned regions a couple of times. Let's give us a little bit more information on that. So a region is a closed area formed by sketch elements or a combination of sketch elements and part edges. We use regions to create a solid feature consisting of planar and non-planar faces. So let's have a look at the types of regions we've got. So we've got a region created by a sketch. We've got a region created by a sketch and a face. We've got the region that's left on the face there. Or, as we did in the previous example, we can do a fence select and select all the sketch regions created and the faces all at the same time. So let's have a look at an example using regions. So here I've created a block as though it's going to be machined. So here we can see that we can select the regions and drag that apart, drag that across. We can use shift to change that. Here we're dragging the region down. Notice we can use that to change that to a cut. Remember, we can use spacebar for that as well. We're dragging this down again. That's, remember, the last option that we've done, so we haven't got to worry about that. Now we go down, that's going to cut those 2 regions at the same time. Here we're going to select 2 regions, so we're going to specify shift to select those 2 regions at the same time. Let's just select the region in the whole, and we're going to cut through on there. We can then add some additional features. So if I go back to my radial menu, right click, we can then do that. We can use the mouse scroll wheel on here to change this size, or we can just input a value if we know exactly what the size needs to be. Even though we've created this as regions, we can physically drag these and it's going to synchronously change. So it's going to recognize exactly how that hole in the cylinder are connected. Okay, so within Synchronous Technology, we don't have a specific sketch environment. We sketch on faces within the normal 3D environment. So we can use the on-screen lock icon or the F3 function key while the cursor is over a face of interest to lock the plane. This remains locked until we use F3 or padlock, which will appear in the top right of the screen. Note we get a green edge which is showing us the plane lock orientation option. We can change this using the N key or B or P. We can see the options on here on the prompt bar. Once we've locked to the plane, we can use a shortcut on the bottom of the screen, or we can use a keyboard shortcut, Control H, to lock to that sketch view. Next, we're going to have a look at some other basic shape creations. So we have a tool called Primitive Shapes that allows us to create 3 possible shapes: a box, a cylinder, and a sphere. While we're creating these, we can use the spacebar to add or remove, but when we create that initial one, notice that we actually are always going to be creating a solid geometry on there. So let's have a little look at an example of a part being made with that. So here I've created one cylinder. I'm using that lock that we just looked at, where we can use that F3 to lock to the planes, to create a 50mm by 50mm cylinder in each direction. So I'm going to create another one on the XY plane at the bottom. So I'm going to use that little lock option, so press F3, start at the center, 50, and then 50 on there. So now we've got a shape that would have taken at least 2 to 3 times as long for us to do that, but we've got a little bit of a cutout on the back. So what we want to have a look at now, we're going to put a sphere in the middle. So I'm going to create a sphere. I'm going to hover over so we can find the actual origin point on there. So once we get to the origin point, we can just click and make a sphere. So we'll make that 42. So this is creating a section going through here, but what we're interested in now is creating a thin wall. So once we've specified the 3mm wall thickness that we want, so we just pop that in, we can just select the faces that we now want to be open faces. So as we do that, we get a dynamic preview, which we don't get on in ordered modeling. So now we've got that, we can just right click to accept. We can now go and add a chamfer onto each of these edges very quickly. So we can just go on there, just select that, and we're going to get a dynamic preview. So at the moment it's showing a large size. So once we've got that, we've now got that. So a very quick way of creating a reasonably complex component very quickly. So next we're going to have a look at the steering wheel. So it's the primary tool for modifying synchronous models. We can use a steering wheel to move and rotate faces, features, reference planes, and sketches. We display the steering wheel by selecting the geometry you want to modify using the steering wheel, be that a feature, a face, a plane. So on the steering wheel, we've got items called different items. So we've got the torus, the tool plane, origin, x-axis, and so forth. So let's have a look at some of the things we can do with the steering wheel. So if we select a face, we're then going to get an arrow. We can then select that arrow, that's then going to move that face in there. That value can be snapped to a key point on another part in an assembly, another feature in that part, or it can be a set value on that part. So we can also use the tool plane. So if we select a feature and then click on the tool plane, which was highlighted orange in there, we can use that to snap. This is very useful if we've got a hole on 2 different parts or in 2 different features on a part, to make sure that we can align those 2 up. So I'm using that, so it's just moving it in that plane direction of that tool plane itself. So we can also use it to do a rotate. So if we grab the steering wheel, move it onto an edge, and if we just move up or down on that edge, it's gonna move the torus, the steering wheel shape item on there. That will then allow us to move that. We can input a value, or we can do that manually, and we can then snap that to another feature if we need to. So when we want to move the steering wheel around, we use the large ball in the center, which is called the origin, and we can snap this to key points. So this allows us to move this, allows us to select a feature, move it to our 0 position, and then we can use the arrows to move this in the distance and direction that we need to. So we can also use the control button when we're moving a feature to create a copy of that item. So control and left mouse button on an axis to make a copy of the selected faces or features on that part. If we're creating a cut, it will just copy the cut faces and add that cut into the additional part. So the last thing I'll look at on this, holding shift will rotate it so it's linked to the different planes. So we're clicking that tool plane again. So just with a shift, that just allows us to rotate it. So if we want to rotate the face in a different direction, we can use this click, and then we can use the torus to rotate that to a different orientation. So moving and rotate faces. So you can see that using the steering wheel, we can use it to move more than just faces. We can use it to move and rotate a plane. So if we want to create a specific sketch plane, we can use it to create a sketch. So if we do a sketch, we'll need to make sure that sketch is deselected from that face and allow us to put that onto another face. We can also fence select multiple features at the same time. So here we've got a protrusion, a sketch, a hole, and they're all moving at the same time. So, and back to the start, moving faces. We can move all those items on the left. Faces, procedural features, occurrences, curves and sketches, reference objects, planes, coordinate systems, model bodies, assembly part faces, and groups. So when we move and rotate face, we've got three different options. We've got extend. What that's going to do, that's going to extend the face, but keep all the side faces the same. We've got tip. This is going to keep the tip size the same, and all the faces are going to change the angle. And the last one is lift. On this example, the round is causing an issue on here, so we're going to delete the round. Now when we do the lift, notice it's going to treat it as though it's just an extrusion going up or down. So let's just see those again. So we've got extend. It's going to extend. It's going to extend the faces that are joining that to match. Tip. It's going to keep that the same size. We can see the back face, the angle is changing on there. And then lift. When we do have that round, we are going to have that problem with the lift if we do have a round on it. So we can see as we now lift that, it's going to treat that just as a straight extrusion. Another thing that we've got, which comes up on the floating bar, is we've got two different priority options. We've got a select set priority, where it's going to keep the feature we've selected the same, or we've got model priority. So when we change to model priority, notice when we move the model towards the edge, the model stops as we get to that edge. So when we are making synchronous changes, both with solid edge models and imported models, we need to think about these different options that we've got available. So design intent. Design intent in 2D, we all know that this is applied within the sketch. We make sure that we've got the appropriate relationships in there. So this panel is looking, so what we need to keep an eye on is a panel on the left. So we're looking at symmetric coplanar. Once we've turned all those options off, it's going to allow us to move those. So when we move that, we can see that we've got symmetric. It's making sure that they move on the two different sides. On here, we've got the symmetry and concentric. For this one, we can see as we go on there, we've got just the symmetry. And it's telling us in the box with that tick. When we move this face, we can see that it's just found symmetric. When I turn that off, it's now found coplanar. So once I've turned that off, it allows me to move the one just by itself. So when we click on a face, this box will tell us what it's looking for. It's looking for all those. But once we start moving it, it's shrunk. Now we've just got symmetric and concentric. As we remove them, it might actually find another one. Symmetric overrides coplanar. So once we turn symmetric off, coplanar then becomes the master one that is running. Selection Manager is used to add items to the select set using the topological and attribute data of a selected face. When active and a face is selected, the dialog box will appear and allows other objects to be quickly added or removed from the selected set of geometry. We can use Shift and Spacebar as a shortcut to activate. So you can see we select that face on there, connected interior faces. It's showing those faces that are connected to that item. Here, if we select that face, and we're going to recognise this as a rib boss, it recognises something that could possibly be made in that way, or as a cutout. So here, if we select that face, we can recognise this as a coplanar faces, or any other options that are on there. So on there, we're going to get connected faces, so all the other faces that are connected to that one. If we select this option on here and select coplanar, it's going to show all of those faces on that part. So next we're going to have a look at feature reuse. So we're going to look at cut, copy and paste. So we select the elements, look at the steering wheel, decide where we want the origin to be for us to repaste it. Standard keyboard shortcuts, Control Copy, Control V, and then we're going to use that F3 to link that. So what that's doing, that's adding the tool plane to that plane, and then we can use standard synchronous operations to align that up. The location and orientation will be replicated when the elements are pasted. So remember, it's very important that we actually make sure that that is in the correct orientation. And the last thing we did there was attach to make sure that geometry is attached. Another tool we have when we're reusing features is detach. This makes it possible to remove faces from the solid model without deleting them entirely. This will disappear, but we can turn this back on our Pathfinder on the left. This works as a suppress-unsuppress operation, also enables reordering of face sets. In this example, you can see we have copied this face, and we're now going to get it into position on the new face that we want this to be on. So last we're going to do the rotate option that we saw earlier. to match the underlying face on here. If we now spin this round and see underneath, you can see that we've actually got a missing face on here. So what this is going to do is to extend all those other faces when we attach it to meet the existing face. So we can select the feature and attach that, and that is now connected to that other part. This is really useful when making change to an existing part. There may be features which are stopping the edit that we want, so we can detach those features, make the edit that we want, and then reattach the features once we have finished the edit that we want to complete. So feature reuse, copy and drag. So we've already seen this, but just covering this again, very, very useful tool. So we have a copy option on the quick bar. We can also press Control while we're dragging it. So we can select multiple input objects. So we can select sketches, planes, protrusions, faces, features are all valid, and we can copy and paste those. So it allows us to make one or two copies very quickly if we don't want to be using a pattern command. So other feature reuse options is mirror. So constructs a mirror copy of selected elements about a plane that we define. The copies are associative but can be broken. We can see on there where it says mirror 16, the lock icon shows that that is actually associative at that point. We could right click on the mirror and click drop, and that would then drop those elements so they're no longer associative. The mirror command is object action, so we have to select the features that we want and then select the mirror command and then select the plane that we want. Features must be selected prior to selecting the command. Mixed face sets are allowed, so we can select different features. We can see on there clearly we've got protrusions, holes, patterns all being selected at the same time and mirroring over to the far side. So other pattern tools, we have multiple pattern tools, standard rectangular and circular ones, and more advanced ones as well, such as pattern and area, pattern by table, pattern along a curve. Patterns only become available after faces have been selected, so this is classed as an object action. And patterns are dynamic and show the pattern as you make changes to the properties. So we can see on here, I'll run through this again. So if we go back to the first option on here, we're going to select the features that we want. So I want to select this cutout and this hole. We're going to select the pattern command, and we're going to drag that to the center point of where the pattern wants to be. Next, we're going to select this cutout. So we're going to use our selection manager. We're going to use tangent chain, and we're going to do a pattern. We're going to drag this to that same center position here. When we change it from 6 to 8, we can dynamically see that changing on there very quickly. So here we're going to select the 3 holes. We're going to do our same pattern, drag it to the center. We can change this to whatever count we want. This would change dynamically as we change that value. So a very nice way of seeing how that works. Deleting geometry. This is something that people quite often overlook. This is a big strength in Synchronous. If you're doing it in order, you'd have to select the geometry that you want. Do you want to heal it? Where do you want it to delete to? So with Synchronous Technology, we can select a face or multiple faces and use the delete key to delete. We have 3 possible outcomes. It's going to delete the faces and heal the connected faces. It's going to delete the faces and creates a new face set in its place. Or it's going to fail due to other faces relying on this feature. So as we can see on there, perfect timing, fails, because we actually need to delete that face. It doesn't know what to do with that small face on there. With this one on the end, we can see that we've got quite a complex option. On these, it's quite easy to actually fence select the entire area and then delete, and we can see that that has now correctly deleted all those. And then back to the first one, very simple one. This is going to recreate, extend those faces to where that needs to be on there. Okay, so let's look at design intent, the face relationships we can create. So this gives the user more control over the model than simple PMI dimensions alone. Similar to applying relations between sketch entities in a 2D sketch. Face relationships directly control the 3D part geometry rather than just the 2D geometry behind the 3D feature. So we can apply lots of different types of relationships, and we'll go through those over the next few slides. So when we do a face relate, we select the seed face, accept, and then select the stationary face. So we can see in this example of a parallel, we select the face that we want to become parallel, accept, and then select the face that we want it to be parallel to. Notice we get a little ghosted option of where it used to be, so we can clearly see that that has moved. So let's have a look at some of the options on here. So this is coplanar with a multiple align. So here we select the faces that we want to move, we select multiple align, and then select the face that we want to move to. It moves both those faces a different amount, so they then match the face on here. By default, we're going to get a persisted relationship. So this is remembered. This is a relationship that is remembered within the pathfinder of the part itself. So if we do this with a single option, the first face is the seed face. The other two are going to stay in the same position in relation to that first face. So if we see, select the second two faces, make sure it's on the single, accept, set the face we want to move it onto. We can see that is clearly moved onto there. So next one, concentric. So this is for working with holes. So we select one hole, accept, and then select the hole we want to link it up with. So with the second one, select the first one, accept, and then the hole we're going to link it up with. So these are persisted by default. So if we move one of those holes, the other one is going to follow it. These relationships can be deleted from the Pathfinder tree at any point if we need to. So symmetry, this is a little bit more complex one. If we've built a part around the coordinate system, we're going to be fine. We're going to get symmetry automatically in our design intent box. And if we haven't built it, if maybe we've used a create in place option, we will need to put a plane in to become. So we can see we've got a plane in the middle of that part that has been applied. What we do, we select the faces we want to move, start to move them, and then notice we haven't got any symmetry on there. So what we do, we click the advanced option, the design intent, and then click the symmetry option that is available on there. So let's just have a look at that. So moving that side, no symmetry. Click on advanced, this box pops up on there, and we can click that little option and then click that plane. That's now going around that plane on there. So notice we selected multiple faces at the same time on there. If we want that symmetry to be remembered, we can actually save that relationship. So we'll see that become available there in blue. Here's a little save icon, bottom left hand corner of the image. We can save that, and that will then save multiple relationships all at the same time to make sure that this part continues working as symmetrical. So next, horizontal vertical. Very similar to the way it works in 2D. Horizontal vertical will make a line become horizontal or vertical. So this is also available for 3D faces. So we can click these in relation to both the base coordinate system, or we can select a secondary coordinate system if we need to. If we want to make a load of faces at 45 degrees, we could create another coordinate system on there. By default, this is a persisted relationship, so those are going to remember that relationship. So if we do make a change on our design intent box, it's going to show that we've got a relationship on there. So where we've got symmetric, concentric, we're going to have a relationship appear on the bottom. Next, we'll have a look at the coplanar axis, or align holes command. So we use this tool to align cylindrical faces to a local or user-defined coplanar axis. The coplanar axis can be defined in a couple of different ways. So how we run this, we select the first hole, this is the seed element, and then we select the other holes which will be orientated by this relate command. And then we select either a planar face, or as in the instance shown below, a point. Once we select the point, all of the holes are lined up between those 2 points. So add in threads. So when we've got imported geometry, it's important that we have threads added. So here we can go to the thread command and we can specify and add a thread. What it's going to do, it's going to recognize a thread, or if we change the thread, it's going to change the size to match the thread itself. If we need to add a tapered thread, so in this instance, we've had to delete the actual tapers from there because the taper will get created automatically from the thread command. So when we go into the thread options and put down the size that we want, we click at the start of where that thread wants to go and then finish, and then we've created the threads on there. Multiple threads are available in multiple different standards, DIN, ANSI, in both straight pipe threads, normal threads and tapered pipe threads. So lots of different options available for threads. Recognize holes. So we have an automated process where cylindrical cutouts are automatically identified and redefined as synchronous procedural hole features rather than just cuts. Specifically for imported models with no features. It's available in both the part and the sheet metal environment. Works on the complete part or the selected face. At the point, once we've created holes, we can physically go in and change those holes, and that will show that as a custom hole. So we can see we've now got multiple hole groups there. Continuing with the same model, we can also look at user-defined sets. So here we're going to use the selection manager to recognize a feature and create this as what we call a user-defined set. So here we've created one rib. Now we're going to select another rib. So once we've selected that, we're going to add to the existing user-defined set and then just click on the set for it to be added to, and that is then part of that set on there. So let's just do another one of those just so we haven't got just the one. So we're going to select those just with a fence select, create user-defined set. It's going to do that straight away. Notice it's also picked up hole 5 and hole 6 and add those to the set because they're within that set as well. We can also rename these as well, so it's easy for us to go and rename those. So from a model that had no information, we've got a hole with multiple features all renamed on that part. Recognize patterns. So this enables finding patterns for any given collection of input faces. Simply pick the master geometry just from one of the pattern instances, and then Solid Edge looks at the model to find the patterns of similar occurrences. Applies only to an ST pattern creation in part and sheet metal on there. Once we've found that pattern, we can also go and change that pattern. So really useful if you want to make a change to something that has got the wrong kind of size. It may be that you've got a tire on the model and you want to show it with more treads, less treads. Really useful option for that. Unexpected design changes. So in this example, we have a fuel tank for a wind-on mower. We've been tasked to make it slightly larger by rotating the front face a small amount. So the face that we're highlighting on there. So when we do go and make that change, so I'm going to make that change to 73 degrees. Yep, that change is fine. Looks okay. But when we look down our list, we can see there's a couple of features that have got warnings: missing parent, key point, thin wall has failed. So we can see that there's other issues on there. So if we look through the hole, we can clearly see that the thin wall has failed. So if I go and do a section through there and just drag that through and spin around, look on the front, we can see that is now a solid part. We haven't actually got that thin wall that we created on there. So what I'm going to do, I'm just going to undo those changes on there. So we'll just change that back to 68, back to how it was. And now what I'm going to do, I'm going to scroll down on the list and I'm just going to select the last feature, right click, move to synchronous. So what that's going to do, that's going to move that feature and every other feature up. If there's something it can't do, it's going to turn that into a face set. So it's recognise that thin wall as a face set. But remember in synchronous, we've got the automatic offset, so we haven't got to worry about that. So now we're going to do that change, but we're not going to look for the feature. We're just going to click straight on the face that we want to change. So we're going to select that face, drag our orientation on our steering wheel down to the round at the bottom. So it's important to make sure this is in the right place. And then we can use that torus, the steering wheel shape on there, to drag that out. So we want that to go -5 degrees. We can see it's telling us that face has changed. There's nothing out. There's no other issues. If there were any issues, they'd be red or black or other coloured faces showing there were issues. So it's only changed those faces on there, and everything else is correct. So a very nice little change. So if we go back into our section, we can clearly see that the thin wall is still working on that part nicely. So very quick design change option on there. So let's have a look what we can do within assemblies. So model edits can be achieved by selecting model faces whilst in the assembly itself. And we can see all those other models changing at the same time. Multiple faces from multiple models may be edited at the same time. It gets rid of the link, the need to link the files together. Face relate tools can be used, but there's no persist option because we're doing it directly from the assembly. We can also create interpart relationships between these parts as well if we do need some kind of automation on that part. Okay, so let's have a do a summary. So Solid Edge Synchronous Technology allows us to easily edit 3D designs without the need to understand the history tree or pre-plan the original design process. The original user's design intent is automatically recognized and can be adjusted on the fly. There's no more failed features after parametric edits, especially something early on that tree. Changing that first option can cause anything to go wrong down on that tree. Graphically and accurately edit geometry using push-pull or add additional control with 3D driving dimensions. We can edit multiple features or even multiple parts simultaneously. We can cut, copy, paste features and drag drop from one model to another for easy design use. It works in harmony with history-based techniques for a true hybrid modelling workflow. So I've got a simple question for you here. Synchronous technology equals return on investment. This is the real benefit of synchronous technology. So for a simple task, we compared synchronous technology with history tree-based modelling, such as Solid Edge or Solidworks for that matter. When we did this, we found we could easily convert 10-minute tasks into 10 seconds. If we can make that simple change once an hour, that generates a return of investment of £53,000 for a small 5-engineer team for simple design edits. So I ask you, are you sure you want to burn £53,000 a year? Synchronous technology equals time savings. This means faster product launches, reduced time spent on repetitive design tasks, means you can invest more time in new ideas and creating new IP. And it will mean increased sales through faster product launch. If you're interested in finding out exactly how much you could save, please visit the website below where it takes you to the official Siemens Synchronous Technology savings calculator. Either go through this yourself or contact one of our account managers to help guide you through it. Thank you for listening. I hope you've learned something. My name's Chris Morgan. My contact details are there. If you have any questions, thank you very much.